Hi, everybody. Hi, everybody. Welcome. My name is Davor Bonacci. I serve as a PMC chair of the Apache Beam project. And today I'm going to give you kind of a quick intro to the Apache Beam project, but also kind of look into the past, how we got here, where the project is going, and kind of what's at the forefront of data processing, and particularly what's at the forefront of streaming. A little bit about me. So I have been at Google. I had been at Google for many years, leading the team that was responsible for Apache Beam. But I am no longer at Google, but still involved in the project and doing things in this space. So let's get started. For those of you that might not be familiar, so Apache Beam is an open source data processing API. It's a way of really simply and neatly expressing both batch and streaming data processing applications, right? So the really thing that went into the design of Apache Beam was to separate data processing logic from runtime environments, basically to raise the level of abstraction so that when you implement your logic, you think about your business logic, your processing rules, as opposed to kind of tweaking the parameters or controlling sharding or other things, right? So no knobs, no control of the execution environment, but really focus on your own business logic. And it was built from the ground up to support portability, execution on multiple processing environments. And that's one of the really key differentiations in Apache Beam, right? If I were to summarize the whole project in one sentence, this sentence would be it, right? Apache Beam is a unified programming model designed to provide efficient and portable data processing pipelines. And these three key things are the key differentiators compared to other technologies, right? Unified programming model, and whereas other projects kind of catch up in some areas of the unified programming model, Apache Beam was the first model to really capture batch and streaming. Efficiency, it's all about running really efficiently on a large-scale machine, right? And there are some talks, especially on this specific conference series, I think 2 years ago, where kind of I focused a lot on efficiency. And finally, portability, right? Ability to run anywhere. So in this talk, I'm going to generally go over kind of where the project has been so far. For those of you that may be new to this space of the project, I'll spend a little bit about talking about the programming model and how do we come up to a real-time system. Then I'll go into a little bit about vision portability, and then I'll try to spend a little more time on the project roadmap and where the space is going and where the innovation is happening right now. So this is not the only talk at this conference about Apache Beam. So later today at 4 o'clock, Holden will talk a little bit about ML use cases and integration of TensorFlow with the big data tools. So I invite all of you to come there. And especially later tonight at 5:40, there will be a Birds of a Feather session where there'll be representatives from multiple streaming projects, and it kind of will be an open session with lots of questions and answers where you can kind of put projects face to face and kind of learn the differences and things like that. So kind of, I would really invite you to come to this session today at 5:40. Okay. Looking back at the history of the project, the project is a little over 2 years old. It started in February of 2016 when Google donated, along with a few other partners, the code base to the Apache Software Foundation to see the project. And basically, 2016 was the year of incubation. Kind of, this is the time where the project kind of really adopted the open source governance, prepared it for kind of wider adoption. And it graduated as a top-level project at the Apache Software Foundation in January of 2017, so kind of a year later. And then 2017 was kind of the year of API stabilization and enterprise growth. So by the middle of last year, kind of we got to the point of the first stable release, right? This is the point where the community started to guarantee API compatibility for the foreseeable future, making it enterprise ready. And then kind of late last year, early this year, we have seen a relatively broad adoption of the project. Okay? So with that, let's go a little bit about how Apache Beam is thinking about data processing use cases and how it unifies batch and streaming, kind of to learn about the way of thinking in this programming model, right? To do that, we have to cover one concept, which is the difference between processing time and event time. If you are going to build a real-time system, we really need to understand that there is time that the event happens. That's what we call event time, right? Something happened, somebody played a game and scored an event, right? That's a game, that's an event that happened at a particular point in time. And then our system will have the ability to process that element at some later point because of various delays, right? And to build a real-time system, we really have to understand this difference between processing time and event time, the skew between them, right? And so if we look at this diagonal line, it represents the ideal case. When event time is equal to the processing time, right? We are processing event exactly when they happen. In reality, there is some degree of skew, and elements have arbitrary delays, and because of these arbitrary delays, things get interesting. So this element number 3 here is delayed relatively little, and this element number 9 is delayed by 5-6 minutes. Perhaps there was some lack of connectivity in our system, and that makes things relatively challenging. And this element is going to cause us trouble down the line. So when we talk about programming models, it's all about answering the questions, right? There is APIs that we have to implement, and when we implement the APIs, we are really answering the questions to the system, right? And there are 4 key questions that are built into the design of a programming model inside Apache Beam. The first question is, what results are calculated? Right? That is your business logic. What do you really want to calculate? And the remaining 3 questions are kind of simple things around your business logic that enable it to run in kind of portable way anywhere from batch to streaming. And I'll walk you through that. Okay? So through the next 3 or 4 slides, I'll walk you through a simple case of summing integers, right? It's a very canonical use case, but it explains kind of how we are building a real-time system. And in the first slide, we are going to answer the first question: what is being computed, right? It's going to be a simple business logic. We are summing integers and producing a collection of key value pairs, string, integer, and summing those integers per key. So one very simple line that basically is kind of a hello world for big data. And really, this single line of code already represents a full pipeline ready for execution in batch mode. And we can run it. And this simulation here represents the execution of that pipeline on this case, right? So we see kind of over time, processing time goes up, because that's kind of real time of the system. As the processing time goes up, we are encountering elements and keeping a total sum. And at the end of the processing, we emit the sum, which is 51, right? This is very canonical batch use case that we achieve with basically 1 line of code at any scale. Obviously, this is not a real-time system. This is not a streaming system. We'll get there by answering the remaining 3 questions. And the second question is, where in event time? If you are going to build a real-time system, we really have to start slicing time, because we can't really wait for all elements. If we wait for all elements, we'll never end up producing anything. To achieve that, we have to do slices of event time. And we do that by making 1-line code change to our example. We answer the second question by windowing the input data into, for example, fixed windows of duration of 2 minutes. By doing so, instead of producing 1 result for the entire summation, we are now producing 4 results. right? And instead of 51, we now have 14, 22, 3, and 12 as those sums. Okay? So we still don't have a real-time system yet, right? But we are building towards it. Still, the results are emitted at the end of calculation. Once we have seen all the elements, now we have the results for each particular window in time. And to get to something that resembles a real-time system, we have to teach the system to start emitting results earlier than end of calculation. And we achieve that by answering the third question in the Beam model, which is when in processing time. We tell the system, we teach the system to output the results, to trigger the output at watermark, which really means when the system thinks it has seen all the results for a window. And now let's look at the animation for this, right? At this point, we have a streaming system, right? This squiggly line represents the watermark. A system's guess or system's heuristic estimation, what elements have they seen so far. And when that watermark passes the end of the window, right, then at that point in time, the system emits results for a given window. Right? Now, as the time goes on, we see the results coming out of the system. This is a streaming system. Okay? And in this particular case, we see kind of for the 3 windows the correct result, but this first window caused the trouble, right? So this element number 9 was delayed more than average of other elements, right? It was unexpected delay, and the system made a mistake. It produced the output of 5 for the first window, but the actual result is 14. Now we need to fix that. And we do that by answering the fourth question of the Beam programming model. We say kind of, if we have to do this, if some element gets emitted much later than, gets into the system much later than expected, we want to be able to refine this result, and we have to specify how those refinements relate, right? We have to understand kind of what are we going to do with this element number 9 that's late. And so we make another 1, 2, 3 line change to our example. And to make things interesting, we'll make it kind of relatively complicated. We'll say that in addition to the result at watermark, we also want early result, just to see kind of where the result is tracking towards, and then late results for every late element. So kind of looking at this line of code, we are requesting early firings. These are early, incomplete, speculative results, and we want that every minute. In addition to that, we want late firings, so late refinements for every late element. So that's at count 1. So for every one of them, we'd like the refinement. And finally, they relate to each other. They are produced in the accumulating mode. So the result is the accumulation of all the results so far. And that's kind of the final animation that I'm going to show you. So let's focus on the first 2 windows here. So in the first window, we have a firing of 5, a result of 5, that is an on-time result. So that is when the watermark passed the end of the window. And then, when we hit the element number 9, we emit 14, which is the late result, which is the final refinement. It's kind of the fixing of result for the first window. And in the second window, we have these kind of early results, right? So the processing of the second window was relatively long, somewhere from 1206 until all the way to 1208. And sort of during that time, we asked for refinements, kind of to see where the result is tracking towards, and then we got 7, 14, and then final on-time result of 22. And at this point, we built a pretty complex streaming system. We built a system that is real-time, that produces correct results, that can process results out of order, that can produce early speculative incomplete results, and it can deal with late data. This is a really powerful system, if you really think about it. And we are able to do all of that with a few lines of code. Moreover, if I look at this code again, right, we can do everything completely separated from your business logic. Regardless how simple your business logic is, summing integers, or very complex, like training machine learning models or doing something very complex. All of these things, big data related, streaming related, distributed systems related, is completely separated from your business logic. And with one line change, we can run it in batch, in streaming, or anywhere in between. And that is really the power of the Apache Beam programming model. Right? So I walked you through, classic batch, windowed batch, streaming, or a complex streaming case with early and late results, and all that with a single line of code. All right. So that's kind of, for anybody that was new to Beam, kind of a quick intro. Now I'll walk a little bit around portability. Right? At the core of the Beam project is the Beam model. Right? It's the abstractions that answer these 4 questions that we just gone through. And those questions are implemented in multiple SDKs. In multiple SDKs in multiple languages. And then, once a pipeline is written in a language, they get executed by a runner. So, in Beam, we provide a model, choice of SDKs, and choice of runners. Kind of the vision is to enable any SDK to run on any runner. Obviously, visions are a journey, and not always the vision kind of represents the reality in the project. So kind of inside the project, Java SDK can truly run on any runner. But Python SDK and Go SDK that are currently inside the project do not run on all runners yet. This is something that is in progress. Obviously, I said this statement at the same conference a year ago, and while we are closer to that vision, we are still working towards that vision. So going deeper into the runner space, kind of 3 main runners are something that users really use today. The first one is Apache Spark. I don't believe Apache Spark requires an introduction at this conference, so I'm just going to skip that. Second runner that is quite often used is Apache Flink. And it's a great project that comes from kind of geographically from Berlin. So it's good to mention it in this in this crowd. It's really good for open source streaming computation, and it can run basically anywhere, both in premise and on the cloud. And then we have, in addition to open source runners, Google has a cloud data flow service, which is a fully managed service inside the cloud platform that can run Apache Beam pipelines. Right, and then Google Cloud Dataflow obviously provides lots of kind of auto-awesome features like auto-scaling, monitoring tools, and things of that nature. So how to think about Apache Beam? Right, so I generally like to think it's just Java. Right, so before Java came along, people were mostly programming in C, C++, and things like that. But once you compile the program would run on a single operating system and single operating system alone. Then kind of Java came along, raised the level of abstraction, and then introduced bytecode and JVM, and then you could run a single Java pipeline, a single Java program on multiple operating systems through the JVM. Apache Beam is the same thing. Right? We raise the level of abstraction from the engine, and then allow that pipeline to run anywhere. And that has been obviously quite popular. .NET Framework is another example of a technology like this. And that's kind of how you can think what Beam is. It's Java, just not general purpose programming, big data, kind of vertical only. All right, so if you're building an abstraction layer over multiple engines, the first question that often gets asked is this a minimal common denominator? Is this kind of, how do these things relate to each other? So first thing that you can do is perhaps create a union of all the runner functionality, right? This doesn't sound very appealing. Why? Because simply put, kind of, it would be a complete mess. And if we try to do the minimum common denominator, kind of being the intersection of runner functionality, kind of that would be quite too limiting, and we would not be able to use kind of advanced feature in any system. So kind of Beam attempts to be at the forefront of what is kind of the state of the art in big data. Beam tries to extract patterns and raise the level of abstraction from individual systems and kind of influence in both directions, if that makes sense. But if we are not the minimal common denominator, that can often mean that not everything can run on every engine, right? Because if the engine doesn't support something, you can't really run it. And that's quite true, right? And to be very direct about it, we try to categorize runner capabilities in something called capability matrix. You can get the kind of the latest snapshot of these statistics from the Beam website. This particular slide may be a little bit out of date, but in general, not every pipeline can run on every engine, but every pipeline can run on multiple ones. So if you are interested in this and you want to get started, quick starts are available on our website. There are example walkthroughs like mobile gaming and word count, and kind of really to get started with a technology like this, right? The Beam website is the place to go. Okay. Now I'm going to switch gears a little bit and talk about integrating the big data ecosystem kind of more towards contributors and kind of committers in the big data space. So besides the SDKs and runners that I already talked about, Apache Beam has multiple additional extensibility points that enable it to integrate with the rest of the ecosystem. Those are DSLs, libraries of transformations, IOs in particular, and file systems. Right? So for example, if you are a committer in some project or you are interested in building big data applications, right? You want to build an SDK for a particular language, I would recommend that those be implemented as Beam SDKs, as a Beam SDK. By connecting to the Beam model, you automatically get the benefit of Beam's diversity, and you have the ability to run those pipelines written in that SDK on any runner. Similarly, if you have an idea how to run a data processing pipeline better than any existing engine, you know of a great optimization, the best way to do that is to implement it as a Beam runner. By doing so, you automatically get access to multiple communities of users, because people writing Java pipelines or Python pipelines or Go pipelines would automatically be able to run on your engine. Right? By packaging it as a Beam runner, you get access to multiple communities for free. And today we have a number of runners and a number of runners kind of in development. Another example of an extensibility points are DSLs. Right? DSLs are really extensions of the SDK to a particular community, to a particular user group that might like a particular way of expressing pipelines better than kind of writing Java pipelines. And for example, Scala is one example of a DSL written on top of Beam to write pipelines easier in Scala. And this specific contribution is made by Spotify. Obviously, kind of, if we are building an ecosystem, it's really important to be able to build libraries of reusable units, kind of packaging useful functionality as a library, as a package. And we can do that in Beam with the concept of P transforms and packaging them and pushing them through the community. TensorFlow is, for example, one example of Beam-based library of transformations. If you want to build big data systems, we really need to be able to connect to storage, right? File systems, databases, and these kinds of things. Apache Beam has one of the biggest set of I/O connectors anywhere. And what is really unique about these I/O connectors is that they are fully scalable and splittable and ready for big data. Kind of, the set of I/O connectors is great, and yeah, I would really kind of encourage you to check it out. And finally, there are extensions in respect to file systems, but I won't go into this too much. It's just to say that we support all the major cloud file systems as well as HDFS, right? So kind of to summarize this kind of developer-oriented section, we think kind of Beam has a chance to integrate the ecosystem. So kind of as a call to action, if you have an engine, think about writing a Beam runner. If you want to extend data processing to a new language, write it as an SDK. If you want to adapt the SDK to a target audience, write a DSL. If you want that component be part of a bigger data processing pipeline, write it as a library. Or if you have a data storage or messaging system, connect it with an I/O connector. So really, I think of Apache Beam as is a glue that can connect the big data ecosystem. Okay. Now, let me just check quickly on the time. Let's talk a little bit about the project roadmap and the future. Kind of what's at the forefront of thinking, in particular in the streaming space. So kind of I like to look at streaming as kind of the pyramid of use cases and the pyramid of needs. At the very bottom is the canonical ETL case, right? At this use case, we are transforming and cleaning data as it arrives and loading it into a long-term storage. This is kind of where the streaming started. I have a data that's coming in. I want to put it in a database and prepare it for later processing, prepare it for batch, right? This first fundamental use case of streaming has been very well solved by now, right? There are many technologies that are pretty good at it. Beam is just one of them. Now, as we kind of start building more complex things on top of it, the second kind of category of use cases is streaming analytics. Streaming analytics use case is, at its core, a stream of data is coming in, and I'm generating a live dashboard, right? I want to see the insight into what's going on in my system by producing real-time analytics of the incoming stream. This example that we looked before about summing integers, think of it as kind of I'm looking at the usage of my system and generating a dashboard and seeing kind of as what's the sum over time. That's an example of streaming analytics. So Beam is pretty good at streaming analytics, as well as some other systems as well. The innovation in streaming analytics these days tends to be kind of raising the level of abstraction further and introducing SQL and introducing simpler ways of expressing analytic workloads. Kind of easier way to generalize and easier way to write the pipeline. And Beam is pushing that same agenda as some other projects as well. And then at the top of the pyramid are real-time actions, right? So in analytics, you are really generating a dashboard, and a human is looking at it. And then a human makes a decision to do something. In real-time actions is really removing the human from the loop. I'm looking for patterns and then doing real-time actions. So that's what's coming after streaming analytics. And again, Beam is pushing that agenda there as well. I'll also say kind of that I'm personally particularly interested in this use case. So if anybody here has a use case like that, I'd love to chat with you. So let's talk about streaming SQL in Beam. So Beam makes this similar and easy to use by building pipelines that mix and match streaming SQL along with the regular Java Beam pipelines. So kind of you can apply a transformation that is automatically generated from a SQL statement. can say something like select this from P collection where ID something, right? And apply that string as a beam transformation. And it's a really cool use case where you can achieve a lot of things simply with SQL, and then for things that may not be expressible in SQL, mix and match with other beam transformations. And this is something that is actively worked by, and I would generally expect this to fully launch and be ready for production by late spring, early summer. And then thing that's kind of at the top of the pyramid that folks are working on are things in the space of real-time actions and finding patterns, for example, through a technology called CEP. And there are a few folks inside the Beam community working specifically on this. I would say that to have this ready for production, we are talking probably late 2018. Other work in progress really, but this particularly is what Google is pushing, is kind of completion of the portability framework. And that completion will enable Python SDK from Beam and Go SDK for Beam to run on other engines, particularly Apache Flink. And kind of this will be the first time that Python and Go are really ready for streaming, ready for batch, can run at scale in a pretty novel way. And then kind of there are other improvements in the project around the build system and performance testing infrastructure and other things that are perhaps a little bit less interesting. Okay? And to summarize, I would like to come back to this single sentence, right? Apache Beam is a unified programming model designed to provide efficient and portable data processing pipelines. I showed you the power of the unified model in that example where we walked one use case from batch to streaming with just a few lines of code changed. I did not touch on efficiency. We touched a little bit on portability. Again, to summarize again, please stay for a session at 4 o'clock and at 5:40 to learn more about the project. And now in the remaining 10 minutes, I would love to answer some questions. Yeah. So, interesting question. So the question is, and please correct me if I'm wrong, can Beam execute Hive SQL statements? So the answer would generally be as follows. Beam uses Apache Calcite as a basis for its SQL. So kind of, I see Apache Calcite as the extension of Hive to be able to do full and complete streaming semantics. So there is no connection between Hive and Beam or Spark, or kind of going back to the Beam's Spark runner at this time. Beam SQL is solely based on Calcite, and then it runs on Spark as any Beam pipeline. Make sense? Okay. More questions? Go ahead. So the question is Beam and smallest common denominator and kind of the functionality inside Beam. So when we kind of started building Beam, we tried to be at the forefront of expressing data processing patterns. We never looked whether a particular engine can or cannot do something. So for example, if I were to look at Beam model versus Apache Spark streaming, there is lots of things in Beam that cannot be executed or expressed as Apache Spark pipelines. That particularly applies with around complex triggering, separation of event time and processing time, and generally the complete streaming semantics are not available in Apache Spark. That does not stop Beam for implementing these kinds of things and running them on Apache Flink or on Google Cloud Airflow. Right? So that's kind of an example where over time Spark is catching up and implementing additional things in streaming that were already part of Beam and Flink. At the same time, there were features inside engines that are not available in Beam. And for example, state in Apache Flink was available probably year or year and a half before it was available in Beam. So it was an example of where Beam had catching up to do and was extracting a useful pattern out of the engine and exposing it at the Beam layer. Right? So there is kind of that cycle where we try to take out useful patterns, but also push requirements into the engine so that more and more things can run anywhere. Does that answer your question? Okay. More questions? All right. Thank you, guys, and I hope to see you at 5:40.